Chapter 8 practice exam number 10. A 9 kilogram point mass and a 1 kilogram point mass are connected by a massless rod 100 meters long. So when I first typed this up and printed out and gave it to you, I forgot to put the length because you really need that. So the person who figured out that I missed, I think, was Jared this morning. And so I said, well, then you get to pick the length. And he picked 100 meters long. So that's why this is a ridiculously long rod, okay? Anyway, you're supposed to find the center of mass of the system and then find the moment of inertia of the system around that center of mass. Okay, so this is actually all the information we need right here. Okay, so let's find the center of mass first. Center of mass. This is the first thing we did when we came back from winter break. Center of mass for point objects will be first object times its position plus the second object times its position divided by all of the mass, all of it. So we're going to just go ahead and call this x equals 0. Okay, where the 9 kilogram is, we're just going to call that 0. In that case, what I have is mass 1 times its position, which is 0, plus mass 2 times its position, which is 100 away, because it's connected by a rod that's 100 away, over both masses. Okay? And what I end up with is 1 times 100, so 100 over 10, which, as you hopefully know, is 10. So the center of mass is, say right there, 10 away from the 9 kilogram, which means that it is 90 meters away from the 1 kilogram. And we're going to need that because for part 2, we need to do the center of mass for point particles, which is the sum of all their masses times all their distances from the pivot point squared. So in this case, we're going to have m1r1 squared plus m2r2 squared. Okay, m1 is 9 kilograms, and it is 10 meters away from the pivot because the pivot is the center of mass. m2 is 1 kilogram. Oop, whoop, whoop, what happened? Ooh, I don't know what happened. It got stuck. Okay, try that again. Okay, and it is 90 meters away. That is going to be a big number. Okay, if you do all that, we end up with, where is it? 9,000, yes. Okay, because you have, you end up with like 8,100 here and then times 1, and then you've got 9 times 100, so 900. 8,100 plus 900 is 9,000 kilogram meters squared. All right, let's talk about points. Unfortunately, there isn't really a lot of places to allot points in this problem because the only equation that you're really expected to know, because it's on your equation sheet, is this one. So I can't really give points for writing out this equation because you're not really expected to know it. In fact, part A you can do kind of just by thinking about it. It's like this one has 9 times the mass of that side, so it should be 9 times closer than that side. I don't know if that makes any sense. So you could kind of work this out in your head, which is, I mean, we don't like it, but it could be done. So what I'm going to do is for this one, I unfortunately am going to weight the answer quite a bit. We're going to make the answer with 4 points and the unit worth 1. Okay, so that's half the points over there. For this one, we can spread it out slightly more, but not a whole lot. I'm going to give you 2 points for writing the equation down, either like this or like this. I'd actually take both, either as the summation or writing it out. There we go. Okay, so that's 2. Going to give you a point for putting the correct, you know what, you just get the right answer. Anyway, we're just going to give you 2 points for the answer and 1 point for the units. Okay, so Yeah, it's kind of funny how they're allotted. Sorry about that.